Hi everybody, I am NAJIH, a PhD student from the Sultan Moulay Slimane University of Morocco, and today I will present my work entitled Characterization of ZnO films elaborated by RF sputtering with different oxygen percentage investigation of surface energy. This work was made by the different authors. The aim of this study is to characterize the thin films layer of the ZnO nanostructure that we have developed. First, identify the crystal structure of different samples by X-ray diffractions, extract topographic parameters and roughness from AFM images, and calculate the surface energy of the different samples. Introduction. Zinc oxide, known as the zincate in its natural state, crystallizes according to the compact hexagonal structure of the word Z type with the following mesh parameters. So, the nanomaterials have been extensively studied for application in various kinds of nanoscale function devices used widely in the several applications: the chemical industry, medical diagnostics, food technology, ultraviolet testing, national defense, and our daily life. Zinc oxide thin film are good candidates upon which to construct functional device because of their low toxicity, good thermal stability, good oxidation resistibility, good biocompatibility, large specific surface area, and high electron mobility. The zinc oxide nanostructured thin films are used in several applications, like surface acoustic wave devices, thin films transistors, solar cells, light emitting diodes, and gas sensors. Elaboration of zinc oxide thin films. The zinc oxide thin films were prepared by RF sputtering. The sputtering was carried out in the gas mixture argon oxygen under RF power 100 watts. The film were deposited with different oxygen percentage for 30 minutes. Characterization techniques. In this study, we used the X-ray diffraction for the structural analysis, the atomic force microscopy for the morphological properties, and the contact angle for the physical-chemical properties. Now, results and discussion. The X-ray diffraction technique is a non-destructive and can mainly characterize crystal quality, grain size, and layer stress state. We can observe that the all deposit ZnO thin films have an hexagonal polycrystalline crystal structure of the word Z type. In our spectra, the sample have only one peak, which appears at the angle close to 34, corresponding to zinc oxide peak 002. Morphological properties. The surface of zinc oxide thin films are characterized by atomic force microscopy. It is observed that the oxygen rate has a direct influence on the topography of the surface of the ZnO thin layers. This variation in the oxygen percentage results in different topography. Also, we have characterized the roughness of the different samples. This figure shows the variation in the roughness of the RMS linear and surface roughness. The increase of the rate of oxygen during the deposit of the zinc oxide thin layers causes a change in the roughness of the surfaces, which explains why the variation of the oxygen percentage influences the structure and topography of the substrate surface. Now we calculate the surface energy. The calculation of the surface energy was made by the acid-base theory by following equation. From this equation we can deduce the components of the surface energy, dispersive and acid-base. We can also define the hydrophobicity from the Van Os model. as following equation. This figure presents the values of the surface energy, dispersive and acid base of thin films of zinc oxide. The surface energy of these films decreases as the percentage of oxygen increases, and the dispersive component has the greatest value, which means that the zinc oxide films have a dispersive character. Here we have decomposed the acid-base component into an acid component and a base component. The results show that ZnO films have an electron acceptor character. The hydrophobicity is a parameter which gives the repulsive or attractive aspect of the surface. The results indicated in this figure shows that the films have a repulsive character, and the degree of hydrophobicity increase according to the increase of the rate of oxygen. Finally, conclusion. In this study, the diversity of results show the influence of the elaboration condition on the topographical, structural, and physicochemical properties. The increase in the percentage of oxygen during the production of zinc oxide thin films has resulted in a decrease in the surface energy and also an increase of the hydrophobicity degrees. This result can be used to make deposits in the form of photovoltaic cells. Thank you for your attention.